All right, so for topic 4, we're going to be looking at solving quadratics by square rooting and factoring. So in Algebra 1, you heard the term quadratics. You may or may not remember it. Quadratics are expressions that have like an x squared or a y squared. Usually it's got an x squared. That's the most common variable. The highest power is 2 of x. So the highest power of the input, which in this case is x, is 2 for a quadratic. Well, let's just start off with this. What number times itself is equal to 36? Well, 6 times 6 is 36. And usually most people just stop there. But we might want to recognize that there is another answer to this problem. -6 times -6 is also equal to 36. This is going to be important for what we're doing later on. So just keep in mind that there are 2 different answers here to this type of question. What number times itself equals 36? Well, when we're solving quadratics by square rooting, solving means we're trying to find out what the variable is. Okay, often it's x. When we solve it by square rooting, what you want to do is you want to start for your first step by isolating the x squared. And what you typically want to do in order to do that is you want to cancel any addition or subtraction first. And then you want to cancel any multiplication or division second. Okay, so your goal is to use inverse operations to get x squared alone. After you've got x squared alone, you would then square root both sides. Now, when you square root both sides, you are going to have a plus or a minus for your answer. There's one thing we need to pay attention to. Note, the square root of a negative answer does not exist. And so if you ever see something like that, what that tells you is that problem has no solution. So we're going to look for that. All right, question number 1. I want to solve this equation for the variable, and if needed, I want to write my answer in simplified radical form. So if I kind of follow the steps that we've got written above, I want to isolate the x squared by canceling any addition or subtraction that's on that same side. I'll do that through inverse operations. So I have this x squared minus 2. I'm going to add 2 to both sides in order to work on isolating the x squared. If I rewrite this, x squared is equal to 16. Now, if I have any multiplication or division, I'd like to do that second, but I don't have that here. So I'm going to move on to step 2, which is to square root both sides. So I will then square root both sides of the equation. What happens is that a square root and a square are inverse operations. So x is equal to, people say the square root of 16 is 4. That is true. That is one of the square roots of 16. And most of the time when we're square rooting things, we just want the positive answer, the principal square root. However, one of the things that we do want to understand is that we want any value of x that would work. Some number x times itself equals 16. Well, that's 4, but that could also be -4. So when you square root both sides, you are going to need to have a plus or a minus in your answer here, because we want to understand that there's both a -4 times -4 would work for x, so would +4 times +4. Just to convince you, in case I haven't, this check would be optional, but if I put in a +4, I'd get 16 minus 2, which indeed equals 12. And if I put in a -4 to the beginning of the equation, -4 squared is 16 minus 2 is still 12. So it works with both answers. Now that check's not required, but if you're feeling anxious about whether or not your answers work, that's how you can do that. Number 2. For number 2, I want to make sure I isolate x squared. I want to cancel any addition or subtraction in this problem first. So I'm going to cancel this -5 by adding 5 to both sides. I'll rewrite this as -4x squared is equal to -40. Next, I'll divide both sides by -4. People may not show all of these steps. They might do some of this in their head. Okay, it may not show this inverse operation. So x squared is equal to 10. And then to cancel the squared, I will square root both sides. So x is equal to plus or minus the square root of 10. Now I should check. The square root of 10 might simplify, but the factors of 10 are just 5 and 2. Notice that there's no factors that are pairs. If there are pairs, I would need to simplify them. If not, I would leave this as plus or minus the square root of 10. Number 3. I'm going to go ahead and start by simplifying this because it just looks kind of funny the way it's written. I'll write this as x squared plus, and I could use a calculator to help me with this. 24 squared, let me get to the right page, there we go. 24 squared, there's a square button on most calculators, is 576. And I could do that same thing with 25 squared, or I could do 25 times 25. Now what I'm going to do is I'm going to start with step 1. I just didn't like the way it was written, so I added in a step. I'll cancel any addition and subtraction here first. And so then x squared is equal to 49. And when I square root both sides, don't forget the plus or minus. X is either positive or negative 7. The square root of 49 is 7 because 7 times 7 is 49. Last problem is number 4 for this part, and then you'll get a chance to try it. I'm going to subtract 11 from both sides, so x squared is equal to negative 4, and I'll square root both sides. But there is no number times itself that could get you a negative, so this right here has no solution. That's because of the negative inside the square root. There's no real answer that times itself could get you a negative 4. So I'm going to have you next please pause the video and try these 4 problems. When you are ready, go ahead and hit start, and then you can see the solution. Number 5, I'm going to get x squared alone. I'll do that by dividing both sides by negative 8. So if I rewrite this, x squared is equal to negative 10. And if I square root both sides, I do have a problem. I've got a negative inside a square root, so I'm going to say there is no solution. By the way, there is a symbol for no solution. It looks like a 0 with a slash through it. I use that symbol a lot. Number 6, 5 squared is really 25, plus x squared is really 36. So I'm just going to write this in a more familiar form. And now I'll cancel. I'll cancel adding 25 with subtracting 25. Rewrite this as x squared is equal to 11. And then I'll square root both sides. Now 11 is prime, so it cannot simplify this. So I am going to leave it as square root of 11. There's no pairs, but I'm going to write plus or minus in the front to show that there are 2 different solutions. Number 7, I'll start by canceling any addition or subtraction. And then I'll rewrite this and divide both sides by 3. So x squared is equal to 1. Now I'll square root both sides. And I don't want to forget that my answer is plus or minus. The square root of 1 is 1 because 1 times itself is 1. Number 8, I will add 6 to both sides to cancel subtracting 6. Next, I'll divide both sides by 2. Rewriting this as x squared is equal to 25. And last, I'll square root both sides. Those will cancel. My final answer is that x is plus or minus 5. So if you have an x squared that you can get alone, you can solve by square rooting. Not all problems have x squareds that you can get alone. Take a look at some of these. I have x squared and an x on number 17. I cannot get that alone. So I'm going to use a different strategy for some of these. This is based on, it's called solving by factoring, and it's based on the zero product property, which says if you have 2 things that are multiplied together and they equal 0, something that is true is that either A is equal to 0, B is equal to 0, or both A and B are both equal to 0. The only way this is saying, basically what this is saying is the only way you can multiply to get a 0 is if at least one of your factors is equal to 0. That's going to be super helpful when we're trying to solve equations where things are multiplied together and they equal 0. Because what that tells us is that either this factor would equal 0 or this factor is equal to 0 or even both of them. So if I solve this, x is equal to 3, or if I subtract 12, which you hopefully can do in your head, x is equal to negative 12. Both of these are possible correct answers for x, so we want to include everything that could possibly give us a 0 here. Now, what I'd love for you to notice is that this factor is x minus 3, and my answer is positive 3. That's because if I plugged in a 3 here, 3 minus 3 would 0 out. This next factor is x plus 12, and my answer is x is negative 12. That's because negative 12 plus 12 would 0 out. Basically, what I'm doing when it's addition and subtraction inside the parentheses, my answer is just the opposite sign that will allow it to 0 out. All right, let's take a look at number 10. Again, I have two things that are being multiplied, and they equal 0. So what this means is that either the first one is equal to 0, or the next factor is equal to 0, or even both of them. But I want to solve this. So this first one, I don't solve with addition and subtraction. I solve with division. And 0 divided by another non-zero number is 0. That's one answer. This one, I could just add 3 to both sides and get that x is positive 3. Notice that when it's an addition or subtraction factor, it's just the opposite sign. That's not true for this multiplication one. When it's multiplication, the variable would have to equal 0. Negative 4 times 0 would create a 0 for that factor. Number 11. Each one of these factors is going to have to equal 0 in order to get all possible answers. Well, the problem here, this first factor, it has no x. 11 cannot ever equal 0. It's just a number. So there's not going to be an answer for anything without an x. I'm going to actually ignore that 11. If it had an x, like it did on number 10, then I would get an answer of 0 from it. Without that x out front, there is no answer there. This one would give me an answer here because it has an x, as would this one. Now, it's great if we can do them in our head. In fact, you might even be ready to just jump straight to an answer for this last one. Since it has subtraction, I want the opposite sign. So x would equal 3. If I check, 3 minus 3 would equal a 0 for that factor. I would like this one to also equal 0. Well, there is addition here. Okay, there is addition or subtraction. So I know I could use the opposite sign, but it's not just that. It can't just be that x is negative 1. If I plug that in, I wouldn't get a 0. So that's not all of it. That's part of it. If I actually do some algebra here, I can see where that negative 1 would come from. But I still have this negative 7 that I need to cancel out. I end up having to divide by it. So I get negative 1/7. Sometimes kids are ready to see this pattern. It's just you change the sign of the addition or subtraction, and then you divide by the coefficient. If you're not ready for that, then just go ahead and set it equal to 0 and use some algebra to isolate. Okay, so go ahead and pause the video. Try these, see if you can get the answers. And once you've got them, you can restart and compare. All right, for number 12, each of these factors will give me an answer for x. This one would just be the opposite sign. Now, if you're not ready to see why it's the opposite sign, you could set that equal to 0 and then solve. But if you're ready to see that it's just the opposite sign, you don't have to show that extra work. And this one, 3 times something would give you a 0. Well, x will have to be a 0. If that makes no sense to you, set that factor equal to 0, and you'll be able to get that same answer of x equals 0 by using some algebra. Notice there's more than one answer. Each factor that has an x will have an answer. Number 13, each one of these is going to give me an answer. This one will give me the answer x is equal to -8. Notice it's the opposite sign. If you're not ready for that, you could say x plus 8 is equal to 0 and then solve it using algebra to get that answer. For the number 13, this answer is x is positive, change the sign, +1, but you have to divide by the coefficient of 2. It'll be 1/2. If that's going to be problematic for you right now, set that whole factor equal to 0, use algebra to solve. You'll get there eventually. It just might take a little bit more work to get to that second answer. Number 14 also only has 2 answers. This 4 out front will not give you an answer because it doesn't have an x. Each of these factors will give you an answer. Here it would be the opposite sign because +2 minus 2 would give you a 0. For this one, we would change the sign of the 11 and divide by the coefficient. If that was really tough for you, you could set that expression equal to 0 and use algebra in order to get x alone, and you're going to get the same answer. Now, sometimes what ends up happening is if you look at 9 through 14, these are all problems that have already been factored. Sometimes you're going to be working with problems that have not yet been factored. So first of all, you want to make sure that you have a 0 on one side. And then what you can do is you can factor the other side, like we practiced in topic 3. And then you can solve it using the zero product property like we did above. All right, let's try a few of these. Number 15, this is a trinomial. We have that equals 0. I'm going to factor this left side. The factors of a squared would split up into a and a. I've got a whole bunch of factors of 8, 1 and 8, and 2 and 4. I want to pick the pair that will add up to 6, so I'll pick 2 and 4. Each one of these factors will give you an answer. This would be a is the opposite sign of -2, because -2 plus 2 would 0 out. This would be a is equal to -4, because if you plug in a -4, it would 0 out that second factor. Number 16, this one is a difference of 2 perfect squares. Notice that we have the equal 0. I'm going to factor the left side. Factors of b squared are b and b. This -25, these are perfect squares. 5 and 5, once with a plus, once with a minus. This would be b is equal to -5, and this would be b is equal to +5. Notice the different signs here. Number 17, this is probably for most students the hardest one at the beginning of the year. This is a GCF. These are not perfect squares like they were in number 16. Well, the number that goes in, the biggest number that goes into 4x squared and 6x is 2. They both have the variable x. And notice how this problem equals 0. Okay, which is why I'm factoring the left-hand side. 2x times another 2x would give you back to 4x squared. And 2x times -3 would give you just -6x. Each one of these factors will give you a solution. I need the outside factor to equal 0, which would make x equal 0. And this 2x minus 3 also needs to equal 0. If you solve this, add 3 and divide by 2, x is 3/2. So now it's time for you to try. Go ahead and pause the video. Try these next 3 problems. When you're ready, you can restart the video. All right, so number 18, I have my equal 0. So I'm going to go and factor the left side. This is a trinomial. X squared will split into x, and my factors of 6 are 1 and 6 and 2 and 3. And now notice there's no negatives in the problem, so I'm not allowed to use any negatives. So I'm only adding, can't subtract. So this is x plus 2 and x plus 3. Doesn't matter in which order you put this. If I then change the signs to solve using the zero product property, x is -2 and -3. Number 19, this would be g. Oops, we've got a little typo here. This needs to equal 0. All right, so this would be G plus 2, G minus 2. So G would equal negative 2 and G would equal positive 2. Notice the sign changes here. And number 20, this one's a GCF. The factors that these have in common, they both have 3 as a factor and H. Notice this is a GCF, you only have one set of parentheses. 3H times H would give you 3H squared. And 3H times, oh boy, we got a couple problems here. This is negative 15H. I'm so sorry. I apologize. 3H times negative 5 would give you negative 15H. All right, so then 3H would have to equal 0, which makes H equal to 0. And H minus 5 would have to equal 0. So we can just use the additive inverse. And that is the end of our notes for topic number 4.